Okay, here we are on our last objective for this particular module. We want to take a look at correcting variables for inflation. And so one of the things we go back to is the difference between real and nominal. Remember, if you have nominal, inflation is included in it. In real, things are not inflation is not included in it. So what we want to do is to take a look at real versus nominal. And so we're going to do that right now. Okay, one way we can use real and nominal is to try to compare different dollar amounts in different times. And so, for example, in looking at the minimum wage of $1.15 in 1964 versus $7.25 in December of 2010, one of the things we're interested in looking at is $1.15 in 1964 the equivalent to $7.25 in 2010. In order to do that, what we have to do is use a formula. There is also a calculator on the Bureau of Labor Statistics which allows you to do this as well. But let's go ahead to the next slide and take a look at the formula. Basically what we're going to do is we're going to say, okay, we have the amount in yesteryear, okay? So year T, and in our case that was 1964, kind of yesteryear if you want to look at it. And then we also need the price level in the current year, or the year that we're talking about. In this case, that would be the 2010, right? So that's our price level today. And then we need the price level in the previous year that we're given, okay? And again, that was 1964, so we need the price level in 1964. So given the information, what we can do is take, okay, we're trying to calculate the what is today's amount, and first we're going to start with the yesteryear amount. So here we're going to start with the $1.15. So we're going to take the $1.15, we're going to multiply that by the CPI today, divided by the CPI of year T, okay, or yesteryear. And what we see is, once we do the calculations, that really $1.15 in 1964 is worth $8.09 in 2010. So really, people are not making as much in 2010 as they were in 1964. Okay. So one of the things we want to do is to be able to compare time series data, but we can't do that unless we strip out inflation. Okay, so that becomes the important piece to this of using the formula that we just presented of the amount in T years multiplied by the price level today divided by the price level in the T year, or the year that we're trying to look. So here's just an example of minimum wage. If we did that for several 2010, and then we use current dollars. Current dollars are nominal dollars, and then adjusted for inflation. And we kind of see the differences in minimum wage. Okay, so let's compare some tuition amounts. Here we have tuition and fees at U.S. colleges and universities from 1990 to 2010. And we have the Consumer Price Index. So express the 1990 tuition figures in 2010 dollars and compute the percentage increase for all three types of schools, which experienced the largest increase in real tuition costs. So this would be something that maybe you're even interested in doing and taking a look at when you started your academic career versus today, kind of where you're at. So in looking at this particular question, I'm going to go ahead and minimize this so we've got it worked out here. There we go. So I'm going to go ahead and minimize that, kind of put it up here so we can still refer to it. And so the first thing that we would want to do is to take a look at the percentage changes amongst the different schools. So if we look at the Consumer Price Index, we can take, again, looking at yesteryear. So I'll just go ahead and work the first one here. So in looking at this, we're going to take, let's see, we're going to take the today's amount, well, yesteryear, we're going to take 9,340, okay, multiply that by the 2010, 218.1, over 130.7. And let's see what we get and how that compares to 2000 in the non-private, or in the private non-4 years. And let's see, I gotta grab my calculator here. Okay, and so if we take the 218.7, divide that by the 130.7, we end up with 1.67329, and I'm going to multiply that by 9340, and I end up with $15,628 and roughly 60 cents. And so we can see that that's a lot, right? The difference is quite dramatic. And what's the percentage increase? Again, take the most recent thing that you're given. We take 27,293 minus 15,628.60. Divided that by 15,628.60, and we end up with roughly a 74%, 634, or roughly 75% increase in tuition in the private non-profit 4 years. So roughly 75%. I should make that correct. Okay, 75%. I mean, tuition's expensive enough, right? Okay, so go ahead and do that for the publics, and kind of take a look at where the biggest increases are, and I think you'll be surprised. So as we see in the data, that the largest increases are on the public 4 years. But again, public 2 years, pretty high as well. So when you look at the differences, it becomes important again to factor in the inflation that we see, and again the changes that we see over time, so that we can use time series data or dollar amounts in different time periods, and we can compare them so that we're really comparing apples to apples. I spoke a little bit about indexation earlier, but again, remember, if something is automatically corrected for inflation, one of the biggest discussions right now in economics is, wouldn't it be interesting if we decided to tie the minimum wage to inflation and index it? It is not. But then again, inflation happens more at a national level, whereas the minimum wage laws happen more at a state level. So when we're looking at those kind of things, that becomes the problems behind how do you go about doing that. The other one I want you to make sure that you understand for the test is the difference between a nominal interest rate and a real interest rate. Remember, nominal has inflation in it. Okay, so nominal has inflation in it, whereas the real does not. It's corrected or stripped of inflation. And this is a great formula here at the bottom. It says that the nominal interest rate minus the inflation rate will give us the real interest rate. And we can move this around in different ways. So this is the way I write it. So the nominal interest rate is equal to the real rate of interest, or the risk-free rate, plus the inflation rate. Now, there are other components to this, like the default risk premium, maturity risk premium, and so on. But what I'm interested in you knowing is just that basically nominal includes inflation, and we've got the real rate of interest, or the risk-free rate, and we add inflation to that to get the nominal rate. Okay, so here's an example. If you deposit $1,000 for 1 year, the nominal interest rate is 9%. And we know that nominal has, that's right, inflation. The inflation rate is 3.5% that year. So if we take the 9%, subtract out the inflation rate, then we end up with the purchasing power that or the amount that you're actually earning. And that's why in the news as of late, especially when we're talking about the Federal Open Market Committee raising interest rates, this is really at the heart of what we're discussing, because it will mean that we will end up paying higher nominal interest rates if we increase the federal funds rate. And we'll discuss that in later chapters. This graph just depicts really the real and nominal interest rates. And so here's a question: what's the difference between the red line and the blue line? if you answered the difference between the red line and the blue line is, dun, 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 that's right, it's inflation. So we get to the nominal interest rate, again, is the real rate plus inflation. Okay, so this kind of sums up this particular module, and hopefully you're ready then to go on and do a PLEA. Thanks.